with Dave O'Gorman and Toby Martin, and at the RVTEC meeting, and we're going to be discussing the SUDS program, which is the
Ship's Underway Data System.
Ship's Underway Data System. Okay, and they got some handy-dandy little boards that they made all by themselves.
It's the serial, it's the analog.
Okay, tell me a little bit more about them.
We designed the whole data acquisition system for the vessel from end to end. We started with the hardware that actually does the acquisition from the sensors, and then Toby here has designed the software that acquires the data from that hardware, processes it, and sends it out to all the appropriate parties. So basically we designed, from one end of design, we designed network data acquisition boards that are time synchronized, powered by power over Ethernet. They synchronize to an NTP server, they acquire the data from the sensors, they timestamp it, and then they broadcast it on the network so that it can be picked up anywhere else on the network and used.
Okay, and so these are the boards?
This is the board here, there's a network connection port there, power over Ethernet hardware here, programming port here, and then it has RS-485 and RS-232. It can get local power in. It can also put power out from the power over Ethernet to power a sensor.
Okay.
This one's the analog board. It's got 4 differential input channels. They can do 0 to 5 volts on 2 of the channels, 0 to 15 volts on 2 of the channels, 4 to 20 milliamps on one of the channels, and frequency from 600 hertz to 20 kilohertz for seabird sensors. This one also has the local power input, power over Ethernet processing, programming, daughter board connector, and local power output power sensor.
Okay, and why did you make these?
Basically, we could make them for a comparable price to regularly available units, but these ones would put out the data that we wanted, like in the format that we wanted with this sort of time stamping we wanted. Toby can talk a lot more about that.
I guess mainly, what was the problem you're trying to solve?
Well, the problem that we're trying to solve is that in the old traditional configuration, you've got a sensor at the bow of the ship and a data acquisition system in the center of the ship a couple hundred feet away somewhere, and you end up running along either a pair of coppers to do the voltage selection or a serial line or something like that, and if you've got 10 sensors up there, you've got a bundle of 10 wires and all that sort of stuff, and in the modern era we've got network everywhere on the ship, and nowadays you can just plug your sensor into one of these boards and plug it into the network, and the data just starts spewing, and you grab it wherever you want.
Okay, and so then with these you can go ahead and just stack them up. So as a scientist comes on board, he can go ahead and say, I want to put my piece of equipment over here. You guys would grab both the digital and an analog solution for being able to interface with the sensor and tie it into your shipboard system.
Yeah, and we can easily add sensors anywhere, and the shipboard software just acquires data from any sensor node on the network automatically. So as soon as you plug a sensor in and plug the board in and turn it on, that data gets acquired.
All right.
And merged into the rest of the stream as well, so it's all got the same timestamps and cross-correlated with everything else that's there.
Yeah, we've made a very large provision for metadata to be added and tagged on every single sample. So all the R2R and SAMOS sort of metadata, all the information about your sensor gets added to a web page that's hosted on the board and saved with the board and broadcast with every sample.
All right, sounds good. I'll go ahead and I'll put a link on the site, and we'll link them right directly to your information on your website.
Right on.
Thanks much.